So we're still in Chapter 4, Applications of Trigonometric Functions, and this section is the law of cosines. So we already talked a little bit today about when we're going to use the law of cosines. So we're going to use it to solve SAS triangles and to solve SSS triangles. And then we're going to solve applied problems, everybody's favorite. Okay, so here is the law of cosines. It says if you want to find side length C, and you know side length A and side length B, so see they each appear twice, and you know the angle C that's between them. So here's side length A and side length B, and the angle C that's between them. So this is side, angle, side. Then the law of cosine says that side length C squared equals A squared plus B squared, which is the beginning of the Pythagorean theorem. But then we have this correction factor, minus 2AB times the cosine of C, because it isn't a right triangle. So then if the combination is, side length A and side length C and angle B, then notice that the side length you can solve for matches the cosine of the angle in the formula, and the other two side lengths each appear twice in the formula. Same thing for if angle A is the one and side lengths B and C, so the formulas are really similar. So let's look at an example of solving an SAS triangle. And I'm going to draw a 10-degree angle, well, a really small angle. I don't know if it's going to be 10 degrees. And I'm going to have side, this is angle B equals 10 degrees. Side length A is 2, and side length C is 1. So it looks like that will work about right for side length B. So as always, I want you to say A equals 2. Oh, I don't know B, so I'm going to calculate it. So that will be approximate. And C equals 1. Angle A, I'm going to calculate, so that will be approximate. Angle B is 10 degrees. And angle C, I don't know, so that's going to be also approximate. So see how I have this set up for the law of cosines. I know two side lengths and the angle in between them. So side length B squared is going to be A squared plus C squared minus 2AC times the cosine of the angle between them. So let's fill in what we know. B squared is 2 squared plus 1 squared minus 2 times 1 times the cosine of 10 degrees. So B squared equals 5 minus 4 cosine 10 degrees. So that's going to be approximately 1.06077 and a bunch of more decimal places. But I want you to keep all of that in your calculator and find the square root so that you have B is going to be approximately 1.03. So we know B is approximately 1.03. But I want you to keep that number in your calculator so that you can recall it when you need it. So notice these purple words here. It says when you have a choice between using the law of sines or the law of cosines, use the law of cosines because there is no ambiguity. There's no ambiguous case with the law of cosines. If the cosine's positive, the angle's smaller than 90. If the cosine's negative, the angle's bigger than 90. So in this case, you might think about using the law of sines, but I'll just warn you, you will have an ambiguous case and you'll have to figure out which one actually works. So this is angle A, and I don't know angle A, but now I know the two sides on either side of angle A, and I know the side opposite. So I'm going to say that side length A squared equals B squared plus C squared minus 2BC cosine of angle A. Well, now I know A, B, and C. The only thing I don't know is the cosine of A, so that's what I'm going to be able to solve for. So I'm going to have 2 squared equals, I'm going to keep the B squared in my calculator because I don't want to approximate it. I want the actual whole value for my calculator. So I'm going to have 4 minus 1, so that's 3, equals b squared minus 2b cosine of a. So now I'm going to subtract b squared from both sides and divide both sides by negative 2b. So I get that the cosine of a is approximately, so I'm going to square my b and subtract it from 3, then divide by negative 2, and divide by b, and I'm going to get the cosine of a is negative 0.94143 and a bunch of more digits. So you can see from this that angle A is bigger than 90 degrees because it has a negative cosine. So you're going to use your calculator to find the inverse cosine of this entire number. Don't round it off. And so that's going to be 160, rounding to 1 decimal place, 0.3 degrees. So we have about 160.3 degrees. Then the easiest way to find the third angle is always going to be to say, well, they have to add up to 180. So if I add 0.7 here, I'm going to get 1. So I have 161 plus this 10 is 171. So I need 9 more. So angle C is 9.7 degrees. So let's see if that seems reasonable. Yeah, look at the picture. That makes sense. This A is really big. So if you used the law of sines, you would get 2 choices for angle A, and you would have to figure out which one it was, because there aren't 2 triangles here, but you get 2 possible values for A. So let's look at number 30, where we know 3 side lengths. So I'm going to put side C here because it's the longest, and then I'm going to say side B is 3 and side A is 4. So we're going to use this idea here again, where if we know 3 side lengths, we can solve for the cosine of one of the angles. So let's start with a squared equals b squared plus c squared minus 2bc cosine of angle A, and that's going to allow us to solve for angle A. So we'll have our a, which is 4 squared, equals b, which is 3 squared, plus 6 squared minus 2 times 3 times 6 cosine of angle A. So I get 16 equals 9 plus 36 minus 36 cosine of A. And then I'll have negative 29 equals negative 36 cosine of A. Dividing both sides by negative 36. And I'll get 29 over 36, positive now, equals the cosine of A. Well, I can tell this angle is going to be smaller than 90 degrees because it has a positive cosine. So A is going to be the inverse cosine of 29 over 36. So that's equal. And then we get approximate 29 over 36, and then inverse cosine of that gives me 36.3 degrees. And then you can find the other angles in a similar way.